let's go down to example 8. Now they have some variables in there. It says add and subtract expressions involving variables. And it's not that much more difficult. And sometimes it's actually easier to see because you're not simplifying numbers like 54. You just have a letter with a exponent above it, and the root becomes the denominator when you make it as a fraction, when you convert the radical to a fraction. Hopefully that makes sense to you. And sometimes you don't need to do that. Like look at these first two. First one's a radical, square root of w, square root of w. Well, right there, you got like terms. So you just have to add the coefficients. And 1/5 plus 3/5, well, they've got a common denominator. So when you add them up, 1/5 plus 3/5, it's just going to be 4/5 square root of w. Second one is written as, fractional exponents. That's okay because you have xy to the 4th and for the first term and xy to the 1/4 also. So they are like terms right there. And we can keep them in that form. We don't have to change it back to radicals. But, so it's 3 minus 8, which is just -5, xy to the 4th. Now again, this is a radical, and let me just show you quick what it looks like if it's written in rad form. It'd be -5 x to the 4th root of y. So that's a radical term as well, but they had it with the exponents instead. Not going to show you this problem here because it's a humdinger, and I've got to be present with you guys and spend some time on this, and we don't have that luxury now, so I'm not going to work on that level of problem. So let's go down here. 13 is also a subtraction problem, and this is a little bit more complex, but it's not the worst thing you're going to see. So let's break this down. We have a square root of 9 and a square root of w5. I want to split that square root between the 9 and the w. I have two bases here. I'm going to split that. So square root of 9, hey man, you should know what that is right away, times the square root of w to the 5th. Now I'm going to do something with that in a moment, and you'll see how we can simplify that. Then I have minus a w, and I have the square root of w to the 3rd, so I'll leave that as it is for now, because I want to do things together with both these terms. All right, to help me simplify radicals, it's nice to have them in the fractional form, because then I can pull things out of the radical. Like when I take this square root of 9, I'm taking that apart, right? That's just plain old naked 3. I can take that square root of 9, I just know it's 3. Likewise, I can take the square root of w to the 5th and pull out a couple w's, and I'll show it to you in a moment how we do that. Clean up the mess a bit. So we know square root of 9 is just plain old 3. Now I'm going to write the w to the 5th with the square root there as a fractional exponent times w to the 5/2. Now look folks, we went back and forth between radicals and rational exponents a lot of times before our break. So hopefully that step there was easy for you. And then we do minus, and do the same thing here. I have w, and I have then times w to the 3/2. Now watch what I do next. What you're going to see here may not look familiar at first, but when you look at it backwards, you'll know that we've done these a lot already, and it should be familiar. So the 3 stays, not going to worry about that. The w to the 5/2, oops, to the 5/2. Watch what I do with that. This thing's moving on me, sorry. Here we go. Watch what I do with this. I'm going to convert that to w to the 4/2 times w to the 1/2. Now, I'm not going to write the rest of the problem. I want you to stop right here and look at that for a second. I took the 5/2 and made it this. Do you remember how, again, this is just before we left, we were taking these kind of problems and combining them because they had the same base? Then you would add the exponents. So 4/2 plus 1/2 would become, ta-da, 5/2. I'm just kind of going backwards to create a nice perfect, I'll show you in a second by perfect. This is a perfect square here. I can pull that out of the radical and it'll be a nice clean W. All right, so on to the other one, the other term. It's minus w, and there's 3 halves. I'm going to write it as times w 2 over 2 times w to the 1 half. Again, the 2 over 2 and the 1 half combine to give me this 3 halves, don't they? I just went backwards. I just ripped it apart. And by doing that, I create a nice perfect square. So let's clean this up and see where we end up in a moment. So we have this 3. This w 4 halves, that's just w squared, right? There's no more radicals with that. And we have the w 1 half. And on the next term, we have the w. And the w to the 1 over 1, or I'm sorry, the w to 2 over 2 is also just plain old w. So it's going to be w times w. We'll clean that up in a moment. And times w to the 1 half. Hope I have enough room here. One more step here. I want to rewrite this as a radical and this as a radical to get us back in our original form. So give me a chance to do that here. So now we're going to have 3w squared w to the square root of w minus, now this w times w is just plain old w squared, right? So this is going to be w squared, and this is going to be the square root of w. And now it's sort of in a similar form that we started with. We had square roots. So now the 3w squared and the minus w squared becomes, I'm going to go this direction, folks. Sorry, I ran out of room. But the 3w squared minus w squared is going to be 2w squared square root of w. That wasn't too bad. And we'll see some more of those later.